time, a concept with countless definitions and perspectives that we can never fully grasp. A person's life is measured in time. The development of things is measured in time. Even the birth and death of the universe are calculated using time. Humans have always sought to define time, understand time, and above all, control time. Perhaps the clearest expression of our desire to grasp and control time is our obsession with time travel. The story of the connection between humankind and time may seem narrow at first glance, but in truth, it is vast and profound. In this video, the primordial universe will bring you a completely new perspective, a viewpoint we have never explored together before. Hello everyone, this is a video about the philosophy and physics of time travel. Let's temporarily set aside the countless concepts, forms, and ways time exists that we see in movies like this one or this one. Surely, we need something more realistic to discuss about time. First of all, it can be said that time is absolutely not the same in every situation. The perception, concept, and division of time differ depending on each individual's perspective. Let's start with the easiest point: categorizing types of time. First, there is time from the scientific perspective. Simply put, scientific time is the division of time into equal segments measured by clocks. It has no color, no qualities of brightness, no afternoon, no evening, no shades. But on a broader level, spring and autumn, summer and winter, whether one is imprisoned or free in the world, time flows irreversibly. Time does not stop, does not wait. It keeps passing, keeps pulling forward. That is the kind of time that is considered equal for everyone, and humans cannot participate in or change anything about it. It is merely the succession of all things, entirely external, cold, mechanical. Simple enough, it's science after all. And if we want to participate in time, humans still have another way of dividing it: physiological time. It is understood as the type of time that, in some way, is influenced by humans. It can be called growth time. Although it is still limited and has not yet extended into the realm of consciousness, it already carries some human quality within it. Because of that, it becomes distorted, stretching and shrinking according to the person, the age, or a bit of mood. Young people have more distinct physiological time than the elderly, since in old age, the body almost no longer develops significantly. For example, a wound on a 5-year-old child will heal faster than that of a 50-year-old. Higher than physiological time, involving human perception, is psychological time. Psychological time is measured by emotions, feelings, and impressions. Depending on the situation, people perceive time as longer or shorter. When we are young, we often feel that time flies quickly because we constantly experience new things and joys. We are swept up in the current of society with countless pieces of knowledge, relationships, and tasks that must be handled in a day. It's not by chance that people say, "A day in prison feels like 1,000 years outside." When freedom is lost, time suddenly feels infinite. Those are the most basic and pure ideas about time. But that is not enough. If we want to grasp and control time, we need a truly profound study of it. And such profound study must definitely come from philosophy, the science of all sciences. There are different schools of thought about the concept of time in philosophy. Most of the reflections on time come from Western philosophy, whereas Eastern philosophy rarely presents much on this matter. Almost all the famous figures commonly divided from the West have discussed time as a serious topic that requires deep research during the years 544 to 583 BC. This figure made an extremely famous statement that we still refer to today. He was Heraclitus, a renowned philosopher of ancient Western philosophy, born into a noble family in Ephesus. But he had to live a life of great suffering and loneliness. under the eyes of Heraclitus. Everything in our world is always changing, moving, and constantly developing. The world is like a flowing river that keeps going forever. And from that perspective came the idea that no one steps into the same river twice. Everything is always changing. These changes happen in succession. They both oppose each other and give birth to each other like light and darkness, hot and cold, day and night. Nothing is stable, like a river, and nothing shifts continuously, like a river even the moment. It seems still is exactly the moment it is transforming. Time has the nature of movement and is never truly still. However, not everyone agrees with this. What I mean is not everyone agrees that time or all things are in motion. The most representative figure is Parmenides, who believed that being is eternal and all changes are merely appearances. Also in this direction, the philosopher Plato believed that besides the changing world of phenomena, there exists a world of ideas of the soul, a world that is eternal, immutable, and beyond time. Meaning there are worlds untouched by time, and time naturally becomes the moving image of eternal immobility. More than 200 years passed until around the 300s BC. We gradually began to see new streams of thought for the scholar Aristotle. The nature of things is change, and he defined the philosophy of nature as the study of transforming things accordingly. Time is the measure of motion, in terms of before and after time is continuous because it belongs to continuity, and only the present time is truly real. Then we witnessed the emergence of a famous philosophical school called Stoicism, which essentially emphasized that knowing what is enough is one of the most valuable aspects of life. A life that is quiet, peaceful, and calm. That tranquility is found through self-restraint or self-mastery, including the ability to control desires and govern oneself. Not allowing indulgence in passions, according to the Stoic school time, has no substance, but all things that are non-existent, and in motion exist within time, is part of the life of the world, that is, of creation itself. Because the universe is nature itself, is creation itself. Therefore, the philosopher Epictetus, a representative thinker of the Stoic school, followed and accepted time lived in accordance with time in harmony with creation. So what about modern philosophy? In the second half of the 17th century, we had Gottfried Wilhelm Leibniz, a scholar who played an important role in European politics and diplomacy of his era. He held equally significant positions in both the history of philosophy and the history of mathematics in philosophy. He is best remembered for his optimism. His conclusion was that our universe is in a limited sense the best possible universe that God could have created. Leibniz believed that time and space are entirely relative and have no substance. Space is the order of things that can coexist, while time is the order of things that can succeed one another but are still related to each other. And that is the very dilemma of time. Because how can we explain the dual nature of time, being both sequential and continuous, both distinct and yet made up of the forming moments themselves? In summary, time is not one but two things. It is both an all-encompassing objective natural law and a subjective human concept. Only humans are conscious of time. Humans are the only beings who know they will die and know that time continuously passes. For humans, there must be time for existence to be real. In Buddhism, when addressing the issue of time and aspects related to the world, the Buddha often taught that with their limited knowledge and minds still full of delusions, humans cannot fully comprehend the question of the origin of the universe. Humans can only understand in a general sense that the formation and destruction of the world happen over long and varied periods of time. The length of each life in every realm depends on the collective karma of sentient beings in that realm. The Buddha taught his disciples not to seek the past and not to long too much for the future. The present moment is the most miraculous and meaningful instant in the elevation of each person living in the present. Is a way of life that the wise have experienced and reminded future generations about. It is through dwelling in that way of life that humans will recognize the unity between themselves and others, between people and all things, to directly perceive that the self is only a faint and distant shadow, and that our own existence always depends on the existence of others and countless other causes and conditions. That is the most representative understanding of time known to humanity through the lens of philosophy. But what about the dream of capturing and controlling time? What have we done so far to realize it? Perhaps philosophy is not the wisest path. We need a different way. Physics may provide that way. The modern understanding of time and causality mostly originates from the theory of general relativity. Einstein combined space and time into one, creating the concept of space-time, which explains how both operate in a highly complex and subtle manner. It has been more than 100 years since general relativity was introduced and experimentally verified with extremely high precision. That is why physicists believe that general relativity is the key to accurately describing the causal structure of the universe. For many decades, people have tried to use general relativity to analyze whether time travel is possible or not. Some equations they proposed suggest that although time loops are entirely compatible with relativity, physics still must be based on mathematics, and these equations would be meaningless if they don't align with practical realities. Time travel is the concept of motion, said to transport a person or physical body from one point in time to another. It is understood similarly to movement between different points in space and is generally executed through a theoretical invention known as a time machine. Such movement could go from the present back to the past or forward into the future. Time travel is a category recognized in philosophy and science fiction. It has a certain degree of support from physics. The theories are usually about quantum mechanics, string theory, or wormholes. To be fair, traveling to the future is much easier than traveling to the past. There is no general consensus about which ancient work represents an early example of a time travel story, because some early texts only contain vague elements that hint at time travel. Ancient legends and folklore only include a few details similar to a character traveling to the future. For example, in Hindu mythology, the Mahabharata mentions the story of King Kakudmi, who was shocked upon returning to Earth to find that many years had passed. Essentially, nowadays, there are three most commonly mentioned methods of time travel. To the future, first is hibernation and waking up in the future, a simple idea. Second is traveling at extremely high speeds. According to relativity, time would pass more slowly for the traveler than for people on Earth. Did you know that even when flying across continents by airplane, we are technically time traveling, though the time difference is extremely small? The third method is approaching the event horizon of a black hole. Because the closer we get to a black hole, the stronger the gravity and the slower time moves. In the movie Interstellar, being near the black hole meant that only a few hours passed there, while 23 years passed for those outside the gravitational field. So how feasible are each of these methods? Are they really useful? With the first method, which is also the most feasible, we could place ourselves in a near-suspended state and wait for technology to advance, then wake up. Today, there are actually people already in cryogenic sleep like that, but that is not truly time travel. Basically, time still passes. The third method is far beyond what current technology can achieve. Think about it. Thousands of years of scientific development have only taken us to the moon. How many more years would it take for a person to leave the solar system, let alone approach a black hole? Therefore, we will focus most on the second method. For example, suppose we have an experiment that takes a very, very long time to get results, say 10,000 years. Suppose time travel technology exists. We would launch that experiment on a spaceship traveling near the speed of light, then wait for it to return to Earth and collect the results. If this idea works, it not only helps us solve the problem of waiting for experimental results, but also allows us to calculate everything, depending on the speed of the spacecraft. However, there are difficulties with this approach. The biggest issue is the enormous amount of energy required for acceleration. Currently, we have no technology capable of creating a vehicle that exceeds the speed of light, because we still have no breakthrough that allows us to bypass Einstein's legendary equation, squared. An existing object is correlated between three quantities: energy, speed, and mass. An object's mass increases with velocity. A mass moving at the speed of light would become infinitely massive. For a spaceship to reach light speed, its mass would need to equal half the mass of the Earth. We certainly don't have the capability to build something like that. To increase the speed of a mass to reach the speed of light, either you need finite acceleration over infinite time, or infinite acceleration over finite time. Both methods require an infinite source of energy, which we currently have no way to achieve. Only massless particles have reached the speed of light, photons. Objects with mass can only reach speeds close to the speed of light. But we might be able to do it if we solve the problem by creating a form of matter with negative energy. Still using the equation E equals mc squared, to create negative energy matter means its mass must be negative, because the speed of light is always a constant. Quantum mechanics tells us that, in theory, negative energy matter can be created in extremely small quantities and exist for extremely short periods of time. At the same time, there is no evidence suggesting that we absolutely cannot create negative energy. Moreover, we can find equations that allow time travel without needing such materials. Therefore, this issue lies only in our current technical limitations or our limited understanding of quantum mechanics. Time travel to the future sounds difficult and distant. This is perhaps the most notable part. Traveling back to the past, because it truly is a difficult problem, both in reality and in theory. If we consider time as a linear flow, like Newton's view, then time travel is basically like a train running along a railway. As time flows, it leaves tracks behind. So is it possible to go backward along those tracks? Because in theory, it's just like opening the train door, jumping off, and walking back along the railway. But the multiverse theory asks, are you sure you won't fall off the track? In reality, the timeline is invisible and colorless. You can feel it but not draw it precisely. So even if you jump off the time train, how would you know which direction to go? It's very easy to step off the track and fall into an infinite state. Even if you successfully return to the past, there's no guarantee you can come back to the present. How can you follow the time train when you're no longer on it? If you run for 1 second, the time train also moves forward 1 second. That's why time travelers could end up getting stuck in the past. But nothing is impossible. As long as the time travel device has a speed fast enough to break the limits of time, everything could be completely different. The most interesting part of traveling to the past lies right here, the paradoxes that arise when we go backward in time. The most famous and hardest to resolve is the grandfather paradox. It is a problem within the paradoxes of time travel, and to put it simply, it is a question that cannot be understood or solved. It was first described by the science fiction writer René Barjavel in his novel Le Voyageur Imprudent, The Reckless Traveler, published in 1917. However, similar issues had been described even earlier. A typical example is the novel By His Bootstraps by Robert A. Heinlein, where a man travels back in time and kills his grandfather before his grandfather marries his grandmother. As a result, his father would never be born, which means the man himself would never be born. So how could he have traveled back in time at all? But if you don't go back in time to kill your grandfather, then your grandfather must still be alive, which means you are born and able to travel through time to kill your grandfather. These two situations cancel each other out, denying the existence of both. This is a kind of logical paradox. Although this theory is named the grandfather paradox, it doesn't specifically refer only to the impossibility of someone being born. More accurately, the concept includes any actions that cause the impossibility of time travel to the past in the first place. The name grandfather paradox is simply the most commonly used term to describe the time travel paradox phenomenon. Another example is when we use scientific knowledge from a certain scientist to create a time machine, then use it to travel back to the past and kill that scientist. If the scientist is killed before inventing that scientific knowledge, then the time machine would never have existed. And if it doesn't exist, how could we go back in time to kill the scientist? It becomes a vicious circle of causes and consequences repeating endlessly. This leads us to the next paradox of traveling to the past, called the predestination paradox. The predestination paradox, or causal loop, is a time travel paradox commonly used in works of science fiction. A causal time loop involves event 1 happening first and being the cause, or at least one of the causes, of event 2, which happens later. And through time travel, event 2 then becomes the cause of event 1. The paradox occurs when a time traveler falls into a loop of predetermined events. When someone travels back in time, event 2 becomes the moment the traveler returns to the past, and event 1 is something the traveler did in the past that made them want to go back to fix it. This paradox proposes that time travelers cannot actually change any event. For example, someone goes back in time to save a person from a traffic accident. In the past, they drive to the accident scene hoping to stop it, but unintentionally, they hit and kill the very person they came back to save. The death that made the future self want to return to the past. This theory is closely related to the ontological paradox, in that there is something whose origin cannot be identified. In this case, the reason for the time travel. The paradox does not imply that there is a grand plan from a higher source. It simply affirms that time is immutable. Time travel is always a kind of destiny, and the chain of events can still happen through causal relationships rather than from any supernatural origin. Similar to the predestination paradox, we have the bootstrap paradox, in which an object or information from the future is sent back to the past and ends up influencing the existence of that very object or information in the present. It's described with an example like this. You go back to the past humming a song from your favorite singer. Then the singer hears it and creates a new song based on it. Now, who created the song? You or the singer? The bootstrap paradox always creates a mystery about the origin of information in many novels. A movie with time travel. To make altering the timeline a feasible task, we must resolve the paradoxes. A common misconception in science fiction is that paradoxes can be created. Time travelers are often warned not to change too much about the past and not to repeat their own past. Examples of this can be found in many time travel-themed films like the Back to the Future trilogy. However, in physics, paradoxes are not actually events that can truly occur, but rather theoretical constructs used to highlight contradictions in the theory itself. In other words, the self-consistency paradox doesn't just suggest that time travel is dangerous, it implies that it might be entirely impossible. This is one of the motivations behind the chronology protection conjecture proposed by theoretical physicist Stephen Hawking, who believed that time travel is impossible. Hawking even conducted a simple experiment to support his argument. He wrote an invitation clearly stating the time and location of a party he hosted, then sent it far into the future, thousands of years later, to invite people from the future to return and attend his party. But how do you send that letter to people thousands of years in the future? It turns out to be very simple. Just place the invitation into a metal box made very securely and bury it underground. Thousands of years later, people in the future will dig it up. They will know the location of the United States and even Hawking's exact GPS position on the timeline. If there is a machine that allows time travel to the past, people from the future would certainly come to Hawking's party. After all, he is a theoretical physicist with enough credibility among humankind. Unfortunately, Hawking waited all day, but no one from the future came to attend his party. These predictions still haven't convinced other scientists. And instead of ruling out time travel because of paradoxes, we can eliminate the paradoxes themselves, and the universe would become much more interesting. To resolve time travel paradoxes, theoretical physicist Igor Dmitrievich Novikov proposed the self-consistency conjecture. The basic idea of this theory is that you can travel to the past, but you cannot change the past. Novikov pointed out that if you went back 5 minutes and tried to destroy the timeline, you would find that it's completely impossible. That's because the laws of physics will attempt to intervene and protect self-consistency from being violated. Applied to Hawking's case, you can travel through time to the past, but you cannot change the past in any way. Even appearing in front of Hawking at the party would be impossible. Physics always has a way to maintain the consistency and the history it has already created. Therefore, if you could actually travel to the past, you might only exist there as an observer, like someone who only has view-only access to a Google Doc and no permission to edit it. But what's the benefit of time travel if you can't change the past? At the very least, it allows us to verify history. If you can't change history, then at least you can know what really happened and check whether what historians recorded is accurate or not. However, even Novikov's self-consistency principle still cannot resolve all paradoxes. Instead, this man proposed a more feasible theory. He is Baruch Shoshani. In his view of time travel, there are multiple histories, and we can actually change one of them. In other words, Solin's idea is similar to what we see in Marvel movies, that many timelines exist simultaneously at once. This could solve any time travel paradox, including the grandfather paradox. Solit said that when you step out of the time machine, you fall into a different timeline, not your own. In that timeline, you can do anything you want, even kill your own grandfather, without changing anything in your original timeline. Because the grandfather in your main timeline is still alive, your father will still be born, and so will you. No paradox happens here at all. For many years, Suzanne has studied time travel paradoxes. Now he is increasingly convinced that time travel is completely possible, but only if our universe allows for the existence of multiple timelines. So the question arises, is it possible that there are multiple timelines in the universe? From the perspective of quantum mechanics, the answer seems to be yes. But these are only speculations. Suzanne is still searching for a theory of time travel that combines multiple histories and is fully compatible with general relativity. Of course, even if such a theory is found, it won't be enough to prove that time travel is possible. But at least it means that time travel is not entirely ruled out by the self-consistency paradox. Although time travel and parallel timelines always appear together in science fiction, researchers have shown that they cannot be separated in the real world. General relativity and quantum mechanics tell us that time travel is possible, and so humanity has every right to dream, even to seriously pursue the idea of building a time machine. A machine that, quite literally, jumps between different timelines and different universes. You know, the present will also become the past someday. So we don't need to go back in time to change the future. Let's change something right now, so that in the future, you won't wish you had a time machine anymore. That is what truly means taking control of time. And our time today has been wonderful with all of you who stayed until this very moment. Don't forget to support Vu Tru Nguyen Tui by subscribing and waiting for the next videos. And now, that's it for this one. Goodbye, see you again, and have a great day.